supervised learning is not a good idea. And as with any technology, it's very important to have a sense of what problems machine learning is good for and what problems it's not good for. In particular, what is inductive learning good for? Okay? And this question actually has some very interesting answers. So here are 4 different situations where inductive learning may be a good idea. The first situation is where nobody knows the answer. The reason you don't have, always think of this comparison, right? I could have this program be learned by a machine learning algorithm from data, or I could have a human write the program, right? If it's better to have a human write the program, then don't bother with the machine learning, right? So another question is under what circumstances is it better to use supervised learning, right? Here's the first one. In a way, it's an obvious one. If people don't know the answer, then they can't program it. Okay? In particular, let's say you're trying to find something that binds to the ACE protease molecule, right? So that it inhibits the AIDS virus, right? It keeps it from multiplying and so forth, right? It would be great to have an answer to this question. Nobody has it, right? The amazing thing is that there are actually many problems where machine learning can find answers that people don't know. So the machine learning really there is doing honest to God discovery. Why would that be the case? Well, people and machines have different strengths, right? People have a lot of varied knowledge and a lot of intelligence, a lot of tactics, problem-solving ways. Machine learning algorithms, on the other hand, they have a lot of power that you can't bring to bear, with your brain on that problem, right? Your brain has a lot of hardware for doing vision and language, but not for other things, right? If your problem is to design a molecule, well, you in the lab can only try so many molecules. If you have a good simulator of these molecules and you've learned to predict whether they're good or bad for your purpose, you can, have your cluster be simulating millions of these all night long at very low cost. Okay? So the learning can have an advantage when it can sift through more data, when it can use more computing power, etc., than the human has. Okay? In many ways, these are very exciting applications of machine learning because they are learning things that weren't even known before. However, even when we're not in that situation, and many or even most of the applications of machine learning are not in that situation, we are in a problem that humans can actually do better, right? So if you could get a human to do it, and the human was cheap enough, then maybe you could just let the human do it, right? But you want to program it. And there's a very big difference between somebody knowing how to do it and somebody knowing how to program it. We spend all our time programming things, so we almost forget that this difference exists. But consider the following. Suppose, for example, that what you're trying to do is character recognition, right? We humans are really, really good at character recognition, right? We can recognize, semi-garbled handwriting, pharmacists can recognize doctors' handwriting, right, in almost superhuman ways, etc., etc. But nobody knows how to write a good program to recognize characters. Nobody. People did that in the beginning. They said, well, what is an R? It has a stroke like this and a stroke like this, and, what is a Q, right? And they programmed all these rules, and then, they broke all the time. This was terribly inaccurate. Okay? So we're in this interesting paradoxical situation where we know how to do something, but we don't know how we know. Another great example of this is, just riding a bike, right? You know how to ride a bike. Can you program a computer to ride a bike? If you figure that out, tell me, because I want to steal your idea and publish it under my own name. Right? It's much easier. So here's the paradox: is that it's much easier to ride a bike than it is to program a computer to ride a bike, because your brain is very powerful. Deep in the lower layers of your brain, particularly in the case of things like riding a bike, it's actually your brainstem that's doing a lot of the work. Your conscious high-level self that writes programs with language has no idea how that works, but your brain knows how to do it. So there are many, driving the car is another example, right? So there are many applications where people know how to do it, but we don't know how to program it. In many ways, this is an ideal problem for supervised learning, right? Because we can generate our supervision by having people do it. In fact, a lot of the early cars that drove themselves, this is exactly what happened, right? You just had the car, right, and the camera pointed at the road, and the person was driving the car, right? And this is the supervision, right? At the end of the day, we have a video of the road, and we have a record of which way the person, turned the wheel. And this is our supervision, right? So if people know how to do it, they can give us supervision. Same thing with character recognition, right? There's a lot of these character recognition data sets. One of them, comes from the post office, right? They're obviously big consumers of this technology, right? And by the way, if it wasn't for machine learning, sending a letter would be a lot more expensive, right? Because it would have to be people figuring out what the address is. But the way these algorithms were trained was by actually having, characters labeled by people. That wasn't very hard to do. And then the machine learning actually figures out how to do it, right? So this can be done. So that's the second class of applications for which supervised learning can be good. But that's not the end of it. Here's another case, right, which also occurs very often. Suppose that, yes, people know how to do it, and yes, they know how to program it. The problem is that it's not cost effective. Because, for example, the thing that you're trying to learn is changing every day. So if you're going to hire someone to programming it, like they have to be programming it every day. And in fact, it might take them more than a day to programming it, at which point, it's already out of date. The stock market is an example of this, right? People have all sorts of rules about how to predict the stock market, but they don't really work. The models that work really change, in some cases depending on the type of investment. It could be on a day-by-day basis or a week-by-week basis or whatnot. Okay? In this case, again, it might be a good idea to use machine learning. Finally, in some sense, this is another version of the same thing, but let's suppose things do not change very rapidly, like they're fairly stable. Like, for example, your taste in movies or your taste in books, right? It doesn't change, that quickly, right? The problem, however, is that for a recommendation system to be useful, right? Think of what Amazon has, right? Or, every e-commerce merchant, worth their salt has. They have a recommendation engine that says, oh, people who bought these books, also bought these. They need one of those for every customer, for every user out there. Okay? Your tastes are stable, but, there's 7 billion of us on this planet. There's, 500 million people or whatever who use Amazon. You can't possibly go hire someone to write a program to model your tastes. That would cost more than the money they'll make from selling you the books. And by the way, it really contributes to Amazon's bottom line. I forget what the statistic is, but a large percentage of their sales come from the recommendation engine. So this is definitely a really, useful technology. But if they had to hire someone to go and model your tastes, it would be a big money loser. So the lesson here is, even when people know how to do it, if you need to do it in a very large number of cases, like, for example, one for every person, then it's probably not cost effective to do it, manually, but machine learning can do it, right? Amazon has your clickstream on their website, or, Walmart, another big consumer of these things, has, your record of the things that you bought every time you went to Walmart, and from that, they can try to figure out what you like to buy and, what they should put on the aisles and whatnot. Okay? Questions so far? Okay. So bear this in mind when you're considering machine learning for an application, right? If your application doesn't fall into these things, and if it doesn't have the characteristic that you don't always have to be completely right, probably not a good idea to use machine learning. For example, you probably don't want to use machine learning to design a network protocol, right? It's a very complicated and intricate thing, and if you get one step wrong, the system breaks. Okay? On the other hand, machine learning keeps being used for things that I didn't think it was good for, so I wouldn't be surprised if tomorrow there was a network protocol designed by machine learning, or maybe there is one already. But in any case, it's good to bear these things in mind.